that allows the stormwater to seep into the ground as it falls rather than running off into the storm drains or waterways. Permeable pavement functions similarly to the sand filters in that they filter the water by forcing it past through the different aggregate size and typically some sort of filter fabric. Therefore, most of the treatment is through the physical or mechanical process. As the precipitation falls into the pavement, it is infiltrates down into the storage basin, where it is slowly released into the surrounding soil. Long-term research on the permeable pavement show that they are effective removal of the pollutants such as suspended solids, total phosphorus, total nitrogen, zinc, motor oil, and copper. In the void spaces, naturally occurring microorganism breakdown, hydrocarbons, and metal adhere. By stopping saltwater from cooling and flowing away, porous pavement can help recharging underlying aquifer and reduce peak flows and flooding. Stormwater pollutants are breakdown in the soil instead of being carried into the surface waters that can be contributing to the health of the ecosystem.
There are 4 types of porous pavement. First is porous asphalt, second is pervious concrete, third one is concrete paver, and the fourth one is the open cell paver. For the application, porous pavement are typically recommended for parking areas and low volume roadways. Additional application of porous pavement are for pedestrian walkways, sidewalks, driveway, bike lane, and shoulder. Also, porous pavement have been used successfully for residential and urban streets as well as highways. Porous pavement can be installed as whole or in part with traditional improvement pavement. When installed in combination with impervious pavement or adjacent to building roof, porous pavement can sufficiently contain and treat the additional runoff generated. In Malaysia, there is not much application of porous pavement for the green concept. For the architectural concept even, porous pavement can be used as a green concept for the project as it can be applied to the cycling hub to enhance the green project to the building or environment.
There are several benefits of porous pavement. First, it is good for highly impervious area. Secondly, it reduces need of the storm water. Thirdly, it is less construction cost and soil enhanced turf system resist compaction increase, evaporation for healthier vegetation. For design criteria of porous pavement, there are previous pavement is typically used in low traffic area including overflow, parking area, emergency vehicle lanes, and pedestrian area. In situ soil should have field verified minimum permeability rates greater than 0.3 inch per hour. The isolated system load bearing surface should be suited to maximum intended loads. Design, and lastly is design should be completed within 48 hours. The limitation and the advantage of the porous pavement is pavement structure initial costs are often higher. However, this may be offset by cost of reduction realized from stormwater infrastructure. Then slope pavement require extra design considerations such as the parking, underground berms, and drainage pipe at low points. Then the third one is potential clogging with dirt and organic debris requiring specialized maintenance such as vacuuming or other cleaning mechanism. Next, the limited use of heavy loading areas where sharp turns are probable. Next is porous pavement should not be conducted where there is a high risk of toxic spill. However, porous pavement have been noted that to contain spill from uncontrolled runoff. last but not least is some variation from standard construction practice. Few key factors must be considered when undertaking a project involving permeable pavement alternative. First of all, choose the correct pavement for the task at hand. Permeable pavement option vary depending upon whether the pavement receives light, moderate or heavy use. Therefore, it is important to choose the right material for the expected use. Second, prepare the sub-base. Choose the appropriate sub-base preparation for the application. The type of the sub-base and the depth of the sub-base material determine the amount of filtration provided, as well as the durability over the times. In location with a poor soil of numerous freeze-thaw cycle, a thicker sub-base is usually required. The third one is installed properly. In many cases, the manufacturer will oversee the installation or recommend certificate contractor. The last one is to understand and carry out maintenance requirement. Appropriate maintenance is critical to continue effectiveness and durability of permeable pavement materials.
Unlike conventional pavement, porous asphalt pavement are typically built over an uncompacted subgrade to maximize infiltration through the soil. Above the uncompacted subgrade is a geotextile fabric which will use to prevent the migration of fine from the subgrade into the storage recharge bag while still allowing for water to pass through. The next layer is a stone reservoir consisting of uniformly graded clean crushed stone with 40% void serving as structural layer and temporarily storing water as it infiltrates into the soil below. To stabilize the surface for paving, a thin 1-inch thick layer of clean, smaller, single-sized crushed stone is often placed on the top. This is called the stabilizing course or choker course. The last layer consists of one or more layers of porous asphalt mixed with interconnected voids that allow water to flow through the pavement into the stone reservoir. These porous asphalt layers consist of asphalt binder, aggregate, sand and recycled materials and are much like a desegregated hot mix asphalt mixture. By limiting the amount of fine, the porous mixtures allow for more air voids. Typically between 16 to 22% is recommended. It should also be noted that in the figure 1, an optional stone edge is shown in resting on the stone reservoir. This will allow rain to infiltrate into the stone reservoir if the porous asphalt surface becomes ineffective due to improper drainage.
As a conclusion, porous pavement have been successfully used for more than 35 years in a variety of the climates around Malaysia. They provide a pavement surface that is also part of the stormwater management system, reducing the stormwater runoff and pollutant and replenishing groundwaters. The number of porous pavement parking lots have been listed more than 20 years with no maintenance other than cleaning. Improvement that have made over the past 20 years in the designing and construction of the porous pavement mix. However, additional research should be conducted to develop improved mix design procedures to reduce the potential of elogging and scuffing of these pavements. There is limited research on the structural values for all layers of porous pavement. Therefore, additional research should be conducted to determine structural values for the porous pavement, mix, and stone reservoir course. Research should be conducted on the rehabilitation of the porous pavement to determine the procedures such as miling, cleaning that it may be used for rehabilitation for these surfaces.